HP storage guy Calvin Zito. We are at HP Discover, and I'm with Priyadarshi, PD. PD, you've been blogging on our blog Around the Storage Block, talking about the requirements for flash, and you've been having that discussion for a few weeks, but now we've got the 7450 that we've announced, the HP 3-part StoreServ 7450. This thing gets an amazing amount of IOPS.
Yep.
550,000 IOPS at under 0.7 milliseconds. What have we done to the architecture to get this amazing performance?
Yeah, hey Calvin, pleasure to be here. Yeah, so on the architecture standpoint, we have done a number of flash-focused enhancements, okay? I'll just touch upon them, and I've been writing about this in my blog. Adaptive reads, for example, the way we read IOs from the flash layer itself, we have customized it now. Any host that is doing a 4K IO, we are going to reading only 4K. That is way different than what we used to do with spinning media, for example.
And that's important because it'll drive even better latency because you're not taking more time to grab bigger chunks of data.
There you go. And in addition, because we are using only 4K, for example, we are much more efficient in backend throughput.
Yep.
First up is adaptive reads and writes, which matches host I/O size for both reads and writes to flash media to avoid unnecessary data reads and writes. Let's look at each of them, starting with reads. To understand this, let me give you an example of how a small 4K read to a hard disk drive would work with HP 3-par. First, the cache page size we use with 3-par is 16 kilobytes. When a host requests a read, we check first to see if we have that in cache. For our 4K read example, it's not in cache, so we have to go to the back-end storage and read the data in. The latency penalty for reading from disk can be from 2 to even 10 milliseconds, as we wait for the disk drive heads to position themselves over the requested data. Since the latency to read the 4 kilobytes is high, we read more data and put it in cache in hopes of a future cache hit and reducing overall latency of future IOs. Now let's look at how adaptive reads work. Again, we look at a 4K read that's not in cache. With flash media, reads are extremely fast, so no spinning mechanical parts, and the penalty of a read miss is minimal. HP 3-par StoreServ 7450 reads only the right amount of data into cache. There are two main benefits: optimized read latency. In an I/O-intensive workload, for 4K I/O, only a 4K block is read in cache, not 16K. This reduces the amount of time required to complete a read operation. There's more efficient back-end throughput. A smaller cache page read optimizes back-end throughput, enabling higher IOPS. For example, 1,000 4K reads to flash results in 4 megabytes per second of back-end throughput, not 16 megabytes a second throughput if we were to read full 16 kilobyte pages.
Another example of flash optimization would be around the write sub that we have done. So we do adaptive writes now. So a host that is writing only 4K, we only go and write 4K at the back end. We don't write the full 16K page sizes. So that's, even though our page size is 16K, as the entire world knows, we're actually going granular than 16K when it comes to reading and writing to flash.
And again, that's going to have a latency benefit, and it's going to have an IOP benefit.
And in addition, because we are very much conservative in writing to flash, it has an endurance benefit. All of a sudden, we can write to flash for a much more longer duration of time.
Yep.
Next, let's look at the HP 3-par adaptive writes, from cache to flash. I'll use the same diagram, but I'm going to show a single 16K cache page that I'm dividing into 4K chunks. Again, let's look at what happens with hard disk drives. First, a host does a 4K write request. We write the 4K to cache using a quarter of the 16 kilobyte cache page. We'll wait to see if we can get a full cache page to write all at once, but regardless, we'll do a 16 kilobyte write to the back-end disk drives. With the 7450 and adaptive writes, we'll write the 4K to the cache page and then write 4K to the back-end flash. Whenever we have a write that is smaller than a 16K cache page size, only part of the cache page becomes dirty, and only the dirty part of the cache page is written to flash. HP 3-par StoreServ manages this with a bitmap for each cache page, and while writing from cache to flash, writes only the changed part of the cache page to flash media. The two benefits I'll highlight are: it optimizes back-end throughput with only the required amount of data being sent to the back end. This also elongates the life of the flash media by reducing writes. One last cache-focused enhancement is something we call autonomic cache offload. HP 3-par StoreServ automatically changes the frequency of data offload from cache to flash based on utilization rates to maximize performance. The 7450 keeps track of read cache hits and keeps hot data in cache, thereby lowering latencies of frequently accessed data. This is done without any user intervention and is needed to optimize for performance. There are other new flash optimized features that we'll talk about on the blog.
This is going to be a great conversation to follow on my blog. You can find that at hp.com/storage/blog. PD, thanks for spending a few minutes with me here today.
It has been a pleasure, Calvin. Thank you.
And for more, you can check out our information from the whole announcements we've done here around storage at Discover. You can find that at hp.com/go/next era.